Heisenberg's uncertainty principle. The uncertainty principle was stated by Werner Karl Heisenberg in 1927. This principle gives a very vital relation, momentum, and position of an object. This principle states that the position and momentum of a particle can't be simultaneously measured with arbitrarily high precision. There is a minimum for the product of the uncertainties of these two measurements. Hence, the formula of the uncertainty principle is given by delta x delta p greater than or equals to h by 4 pi. Werner Karl Heisenberg. The German physicist Werner Heisenberg 1901 to 1976 received the Nobel Prize in Physics in 1932 for his work in nuclear physics and quantum theory. The paper on the uncertainty relation is his most important contribution to the physics. In 1927, Heisenberg stated this uncertainty principle that a particles momentum and position can't both be determined. This means that the subatomic events have to be predicted using the probabilities. He was a very talented and intelligent student. Heisenberg impressed his teachers with his ambition and brilliance. He never produced other grades than a straight A's, A grades, except one occasion during his doctorate. Professor Wien of the University of the Munich gave him a F in experimental physics because he handled the laboratory equipments clumsily. Heisenberg realized that in the world of very small particles, one cannot measure any property of a particle without interacting with it in some way. This introduces an unavoidable uncertainty into the result. One can never measure all the properties exactly. Measure the position and momentum of an electron. Shine light on electron and the detector reflects light using a microscope. Minimum uncertainty in its position is given by the wavelength of the light. So, to determine the position accurately, it is necessary to light with a shorter wavelength. By Planck's law, E is equal to h nu hc by lambda. Photon with a short wavelength has a larger energy. Thus, it would impart the large kick to the electron. But to determine its momentum accurately, electron must only be given a small kick. And this means using the light of a longer wavelength. Fundamental traits. Use light with short wavelength. Accurate measurement of a position but not the momentum. Use light with a long wavelength. Accurate measurements of a momentum but not the position. Heisenberg's uncertainty principle. The more accurately you know the position, that is, the smaller delta x is. The less accurately you know the momentum, that is, the larger momentum is there, and vice versa. Delta x into delta p greater than or equals to h by 2 pi. Here hp is the uncertainty in momentum, h delta x is the uncertainty in position. Implications. It is impossible to know both the position and the momentum exactly, that is, delta x is equal to 0 and delta p is equal to 0. These uncertainties are inherent in the physical world and have nothing to do with the skill of the observation. Because h is so small, these uncertainties are not observable in the normal everyday situations. Examples. A pitcher throws a 0.1 kg basketball at 40 meters per second. Momentum is 0.1 into 40, you will get 4 kg meter per second. Suppose the momentum is measured to an accuracy of the delta p is equal to 0 into 0.01 into p, that is 4 into 10 to the power of minus 2 kg meter per second square. The uncertainty position is then delta x greater than or equal to h by 4 pi h delta p, and 1.3 into 10 to the power of minus 33. No wonder one does not observe the effects of the uncertainty principle in everyday life. The more accurately we know the energy of a body, the less accurately we know how long it possessed that energy. The energy can be known with the perfect precision only if the measurement is made over an infinite period of time. Introduction. Wave particle duality. Wave particle duality postulates that all the particles exhibit both the particle and wave particles. Light was thought either it consists of waves, eigen, and particles by the Newton. The first is to publicity hypothesized about the nature of the light and proposed that light is a disturbance in the element of air and was Aristotle. However, the Democritus, who was the original atomist, and argued that all the things in the universe are composed of individual subcomponents. Through the work of the Max Planck and Albert Einstein, Niels Bohr, and many others, current scientific theory holds that all the particles also have the wave nature, vice versa. Thus, phenomenon has been verified not only for the elementary particles but also for the compound particles like atoms and even the molecules. So, what is wave particle duality? The wave particle duality is the principle of the quantum physics. Holds that the matter and the light exhibits the behavior of the both and waves and particles depending upon the circumstances of the experiment. It is a complex topic and but among the most intriguing in physics. Wave particle duality in light. The light is able to function both the particle and the wave depending upon how the experiment is conducted when observations are made. Under the certain conditions, such as when we shine it through the narrow slit and look at the result, it behaves and only under other conditions, such as when we shine into a metal and examine the spray of the electrons of the comes out of the light behaves as a particle. Thus, multiple personality of light is referred as the wave particle duality, and light behaves as a wave or the particles depends upon what. Just like light is a matter is also capable of exhibiting the particles of both the wavelengths and particles. Massive objects exhibits very small and wavelengths also small. In fact, that rather the pointless up to that them in waveform. However, in all the objects of their wavelength is observable and in some cases significant. The significance of the discovery. These discoveries allow the behavior of the light and the matter to be able to be explained through the use of the different equations which represents the wave function, which is at the heart of the quantum mechanics. We need the concept of the alternating the photoelectromagnetic fields to explain the certain physical phenomena like the interference pattern in the two slits experiment. So we keep that. We must somehow explain how a particle's orders of the magnitude smaller than the distance between the slits somehow passes through both the slits and interferences with itself. However, we cannot explain his well using the quanta, and we have the nations give a simply easy to understand the explanation. We need the concept of the quanta to explain other phenomena like photoelectric effects, so we keep that too. But this means we use the different mutual exclusion systems of the mechanisms to explain the electromagnetic radiation.